Okay, this problem says consider the circuits shown below. So we'll have to use Kirchhoff's rules to solve this. They're the same circuit. Okay. Oh no. So this battery is flipped. Okay. What is the current through each resistor in part A? What is the current through each resistor in part B? What is the power dissipated or consumed by each circuit? What is the power supplied to each circuit? Alright, I'll just do one problem. So I'll do this problem, part A. Okay, so let me draw this R1, R2, R1, R2, R3. We'll call this current I3, I2, and I1. And this is 1.6 volts, 1.4 volts. So the junction rule at this point gives us I1 equal to I2 plus I3. Okay, so that's the junction rule. And that rule is current in is equal to current out. So that's the junction rule. Current into a junction is equal to this current, sum of currents out of a junction. Alright, and then we'll apply a loop rule. We'll take this as loop 1 and this as loop 2. Okay, so for loop 1, the equation is, we'll start off here, plus, so we go across this, that's plus 1.6 volts, and then you go across this, that's minus, current flows from the higher to lower voltage, so that's minus I1 R1, and then you go across this, minus I2 R2, minus I2 R2, and you come back to your starting point, so this should add up to 0. Okay, and that's the voltage rule. So 1.6 minus R1 is 2 kilo ohms, I1 R1 is 2 kilo ohms. So we'll keep the resistors. So if the resistors are in kilo ohms, the currents will work out in milliamps. So we'll just keep them in kilo ohms. Okay, so that'll be 2 minus I2 is I2 R2 is 1, so minus I2 equal to 0. Okay, again, so I'll make a notation here: resistors in kilo ohms, currents in milliamps. Okay, so those are our units, and then and then for loop 2, we'll start off here, go around like that, and come back. So for loop 2, the equation is 1.4 volts minus I1 R1 minus I3 R3 equal to 0. So 1.4 into 1.4 into I1 R1. R1 is 2 kilo ohms, so minus 2 I1, and R3 is 1 kilo ohm, so minus I3 equal to 0. Alright, so let's gather all three equations. So here what we'll solve: I1 equal to I2 plus I3 That's equation 1. The second equation is here's our second equation. So 2I1 minus I2, 2I1 plus I2 equal to 1.6. Okay, and so that's equation 2. And the third equation is 2I1 plus I3 equal to 1.4. Okay, so that's 3. Okay, so here's what we'll do to solve this. Okay, so if we add 2 and 3, what we get is 4I1 plus I2 plus I3 equal to 3. But I1 plus I2 plus I3 is I1, so we get 4I1 plus I1 equal to 3, 5I1 equal to 3, I1 equal to 0.6 milliamps. Okay, and then we'll substitute this in one of these equations in this equation to solve for I2. Okay, so 2 times 0.6 milliamps plus I2 equal to 1.6, so that's that gives us I2 equal to 0.4 milliamps, and so that gives us I3 equal to 0.6, 0.2 milliamps. Okay, so we've solved all the currents in each resistor. What is the current for each resistor? What is the power dissipated or consumed by each circuit? What is the power supply to each circuit? Okay, so let's add another page. Okay, so power dissipated by each circuit, P1 equal to I squared R1, I1 squared R1. So I1 is 0.6 milliamp squared, and R1 is R1 is 2 kilo ohms. And so this is equal to 0.36. So 0.72 milliwatts. That's P1. P2 similarly is I2 squared times R2, which is 0.4 milliamps squared times R2 is, what is R2? 1 kilo ohm. So that's 0.16 milliwatt. So what happened was one of the millis killed the kilo, and then ampere square times ohm is watts, and then you have the 1 milliwatt left. So P2 is that. P3 similarly is I3 squared R3, which is 0.2 milliamps squared times 1 kilo ohms, and P3 is 0.04 milliwatt. Okay, so P1 plus P2 plus P3 is 0.72 plus 0.16 plus 0.04 equal to 1688.92.92 millivolts. So that's the power dissipated by the resistors, and so the two batteries must supply that power. So power delivered by the batteries is V1 V1, the current flowing out of this battery is I2, and the current flowing out of this battery is I3. So it's V1 I2 plus V2 I3. V1 is 1.6 volts times I2 is 0.4 milliamps plus 1.4 volts times 0.2 milliamps. Times 64 plus 0.2880, and that's equal to 0.92 millivolts. Okay, so the power supplied by the batteries, this is the net power supplied by the batteries, and that's equal to the power dissipated in the resistors. All right, that I believe finishes that problem. Okay, so that was D. Okay.